Hello everyone, this is actually our third video on indeterminate limits. In our previous video we discussed different forms of indeterminate limits and how we actually can identify those types of limits, and then we discussed a few approaches for solving indeterminate limits, actually 3 different approaches for solving of indeterminate limits. And in this video my focus is going to be again on approaches, and I'm going to cover 3 more approaches for solving indeterminate limits. The first approach that I'm going to focus is expanding. Assume that we have an example like x plus 1 squared minus 1 over x, and x is approaching to 0. So let's start. As we discussed before, the first step for solving any limit is to plug in the value that we are approaching to it, and we do the same thing in here. So what we have to do is we just plug in 0, so it's going to be 0 plus 1 squared minus 1 over 0, and that will generate 0 over 0. But as you can see in the problem, we cannot use any sort of factoring, but one thing that we can do is the expanding, and basically we can open up the parentheses that we have. So using that expanding can convert the equation in the form of x squared plus 2x plus 1 over x as x approaching to 0. Now what we have, it's going to be minus 1, 2. So now what we have is x squared plus 2x plus 1 minus 1, and that will be converted to the limit of x approaching to 0, x squared plus 2x over x. Now if we plug in 0 instead of x, what we will have is again 0 over 0. What we can do is the factoring. So we can do the factoring here. It's going to be the limit of factoring of x will generate x times x plus 2 over x, and x is approaching to 0. Now we can cancel the x that we have on top and bottom, and that is going to be the limit of x plus 2 and x approaching to 0, and at the end the answer is going to be in the form of, we just need to plug in 0 in there, so the answer is going to be 2. So what we did in here, we initially looked at the problem, plugged in the value that we are approaching, and then we noticed, okay, this is an indeterminate form, but what we can do is actually the expanding and actually opening up the parentheses that we have. And then once we did that, we plugged in again the value that we are approaching and noticed, okay, this is again 0 over 0, but with one simple factoring we can cancel that 0 over 0, and we can get the final value as the answer of this problem. Okay, let's look at the second approach, or let's say the common form of limit that you probably see in your exams or assignments, which is the form of functions with absolute terms. And as you see in here, we have the absolute value of x minus 4 over x squared minus 16, and x is approaching to 4. So what we have in here, if we plug in 4 instead of x, it's going to generate for us 0 over 0 again. Let's try it. So if we plug in 4 instead of x, so it's going to be 4 squared minus 16, and this is going to be 0 over 0. So this is an indeterminate form, But what we have to do for the functions like in which we have absolute term, we have to see how we can actually tackle the absolute term in the function. So generally when we have absolute term, let's recall the general concept here. Basically when we have the absolute function, it is equal to positive x when x bigger than or equal to 0, and it will be minus or negative x when x is less than 0. So whatever you plug in there at the end will generate a positive value based on this definition in here. Now we have x minus 4 inside the absolute function. So it is actually x minus 4 so it's going to be positive x minus 4 when x bigger than or equal to 4, or negative x minus 4 when x is less than 4. So we have two cases and we have to check this limit for two different cases to see if this limit exists for whole domain of this function. Let's try it. So if we look at the function now, we have two cases in which one x in which actually x bigger than 4, and for the other case x is less than 4. So what we can do in here, we can say, okay, this is going to be the limit of x minus 4 over x squared minus 16, and when we are on the side of actually bigger than 4, so it's going to be when x is approaching to the 4 from the positive side. Yeah, so based on that, if we look at this function, this is going to be x minus 4 over x minus 4 x plus 4, the limit, and x is approaching to the 4 positive, and then this x minus 4 is going to be cancelled with this x minus 4, and at the end we will have 1 over 4 plus 4, that is going to be 1 over 8. So this is the answer of this limit when we are approaching to 4 from the actually right side. Now let's look at this limit when we are approaching from the left side of number 4. So in that case, this limit is going to be converted to, let's use another color. This is going to be the limit of minus x minus 4 over x minus 4 x plus 4, and again we can cancel this x minus 4. This time it is approaching to 4 from negatives, actually from left side, so this is going to be minus 1. This is going to be the limit of minus 1 over x plus 4, and x is approaching to the 4 from left side. So the answer is going to be minus 1 over 8. So what we can understand from this problem, if we approach to 4 from right side, the answer is 1 over 8. If we approach to 4 from left side, the answer is minus 1 over 8. So the limit exists if we approach from right side, the limit exists if we approach from left side, but as these two limits are not the same, the overall limit doesn't exist. So the answer for this problem, if it is asking for the limit of the function when x is approaching to 4, doesn't exist. So the answer is going to be this limit doesn't exist. So the general approach for this type of limits is to actually look at the concept of absolute value, looking at the limit from right and left side, and once you have the limit from right and left side, you can decide if this limit is actually a possible limit, if this limit exists or not. Okay, let's look at the third one. And for the third one, we are looking at one, I would say one property of limit basically, but it is not a property, but here I'm just calling it as a property, and it's related to trigonometric function. And this says if we have the limit of sine of theta over theta when theta is approaching to 0, the limit is 1, and the other one is the limit of tan of theta over theta when theta is approaching to 0, and it is again 1. So I'm not going to provide the proof for this too. I want to show how we can use these two concepts, and my focus is going to be on the first one. So let's look at the first example that I have in here. We have the limit of sine 4x over x, and the approach says, okay, we should have theta. So the variable is theta. So it can be anything basically. So you can put any variable instead of theta and fix it and solve it and use this, let's say, property. So what we have here, we have the sine 4x over x when x is approaching to 0, and what we can do is we have to make it in the form of theta. So whatever we have in here should exist on the bottom. So what we can do, we can actually multiply the top and bottom to 4. So this is going to be the limit of sine 4x over 4 times x, and the top part is going to be multiplied by 4, and at the end we will have the sine of 4x over 4x times 4 when x is approaching to 0, and this will generate 1 times 4, which is going to be the 4 as the final answer of this problem. Easy. The second problem that I'm going to solve, and actually I'm going to put it as an example for you guys, and you guys should focus on it as an assignment, is the limit of sine x plus 3 over x plus 3 times x plus 4 when x is approaching to minus 3. So you have to use this concept, this property, in order to solve this problem. And I will give you the answer in our next lecture. Thank you very much for watching this video. Hope you enjoyed. If you enjoyed, please subscribe our channel.